Modulation is the process of superimposing the information content of a modulating signal on a carrier signal, which is of high frequency, by varying the characteristics of carrier signal. Characteristics such as amplitude, phase, or frequency of the characteristics in accordance with the modulating signal. Modulation mainly classified to two types based on the nature of carrier signal. It is continuous wave modulation and pulse modulation. So, modulation consists of two types of signals, message signal and carrier signal. Modulation is classified to two types based on the nature of carrier signal, whether it is continuous or discrete. So I think it is clear for you. I'll once again tell. Modulation means it consists of two types of modulation. It consists of two signals. It involves two signals. One is message signal and the other one is carrier signal. Now, it is classified to two categories based on the nature of carrier alone. So, it is called a continuous time modulation I'll write like this, and it is pulse modulation. This classification is based on the nature of carrier. Here, carrier is continuous. I think everybody knows what is continuous by now. Continuous is analog signal. It will continuously change over time. Pulse modulation means your carrier will be discrete or pulse or discrete, like it will be like on, off, on, like that. So, modulation is classified to two types: continuous time modulation where carrier is continuous signal, pulse modulation where carrier is pulse type. Now, we are not telling about the nature of message signal. So, here continuous time modulation only we are telling carrier is continuous. Message can be continuous or message can be discrete. In pulse modulation also message can be continuous or message can be discrete. So again, based on the nature of message signal, again this continuous time modulation is classified again to two types based on the nature of message signal. They are analog, simply I can say it is analog modulation or continuous time analog modulation. It is simply I can say analog modulation, and this one will say as digital modulation. In simple words, analog modulation and digital modulation. So here carrier is continuous and your message also continuous. Message also continuous. Digital modulation, carrier is continuous but message is discrete. It will be in zeros and ones. Message is discrete. So hope this is clear for you now. Continuous time modulation, again it is classified to two types: analog modulation and digital modulation, or in other terms I can say analog continuous time modulation and digital continuous time modulation. Analog continuous time modulation, your message is also continuous. Carrier is continuous, message is continuous. In digital modulation, carrier is continuous but message is discrete. So examples is, this is you have studied in your communication system. Examples are AM amplitude modulation, FM frequency modulation, PM phase modulation. Digital modulation examples are ASK, amplitude shift keying, you will study in detail in unit 3. Frequency shift keying, FSK, you will study in detail unit 3. And phase modulate and PSK, phase shift keying, you will study in detail unit. Amplitude shift keying ASK, frequency shift keying FSK, and phase shift keying PSK. All you will study in detail unit 3. So this is the examples of analog analog modulation. We have studied this here, and already we have studied in your communication system analog modulation. AM amplitude modulation, FM frequency modulation, PM phase modulation. See, this is the carrier. Carrier is high frequency, continuous in nature. This is a modulating signal. It is low frequency, continuous in nature. Both carrier is continuous, message is continuous. Resulted in amplitude modulation AM, phase modulation PM, and frequency modulation FM. Look here, you are changing the characteristics of carrier. This is carrier is of fixed frequency, fixed amplitude. When it comes to the amplitude modulation, frequency of the carrier is same, but amplitude of the carrier will change according to the modulating signal, according to the instantaneous amplitude of modulating signal. When it comes to the FM, frequency amplitude of carrier is same, constant all over, but frequency of the carrier, FM it is, frequency of the carrier will change according to the instantaneous amplitude of modulating signals. Look here, when amplitude goes low, frequency is high. When amplitude goes high, frequency is low of the carrier. Similarly, phase modulation. Now, comes to the digital modulation. Carrier is continuous, message is discrete. So these are the digital modulation. Look here, message is discrete in terms of zeros and ones, and carrier will be continuous in nature. ASK, amplitude shift key. See this position, when it is 0, carrier is 0 amplitude. When it is 1, the carrier like that. When again 0, carrier is 0. So it is not a gradual change. Amplitude of carrier is shifting according to your message signal. So that is ASK. Amplitude of carrier signal is shifting in accordance with the amplitude of your binary message. ASK. Similarly, FSK. FSK means frequency of the carrier signal will shift in accordance with the binary message. Look here, when it is 0, you can see a high frequency. When the input signal, when the message signal is 1, you can see a low frequency. Here a low frequency, this is a high frequency. Again 0, a low frequency. Again 1, a high frequency. So, frequency is shifting from when message signal goes from 0 to 1, frequency is shifting. It is not a gradual change again. So, FSK means frequency of the carrier signal will shift in accordance with the amplitude of your message signal. Now comes to the PSK, phase shift key. Phase of the carrier will shift in accordance with the amplitude of your message. Look here, when it is 0, your carrier signal is like this. When it changes from 0 to 1, the phase is not continuous, it is shifting. Again from 1 to 0, phase is shifting. So, phase of the carrier will shift according to the amplitude of your message. That is called the phase shift key. So, modulation, I think now continuous time modulation is clear. Modulation is classified into two types based on carrier continuous and carrier pulse. Continuous time modulation and pulse modulation. Now here message can be continuous and message can be discrete. So remember one thing, in digital modulation, when we are telling it is digital modulation, message will be discrete. Message will be digital. So this is digital modulation. Message is digital here. So here carrier is continuous and message is digital. So it is digital modulation. Now comes here similar to the classification of pulse modulation. Pulse modulation is carrier is pulse, and again based on the nature of your message signal it can be again classified to two types. One is called message is continuous in nature. It is called analog pulse modulation. Analog pulse modulation. That means your message is continuous. Message is continuous like this. Now again it is classified to another type based on message is discrete. It is called a digital pulse modulation. Here your message will be discrete. Message is discrete in terms of ones and zeros. It is not continuous, it is ones and zeros. So remember, this under digital modulation only these two will come. Message is discrete, message is discrete. So here message is discrete, ASK, FSK and BSK. Here also digital pulse modulation, message is discrete. And examples of this is of again another category of analog modulation only. This is another category of analog modulation because message is continuous only. Here the examples are PAM, pulse amplitude modulation, pulse width modulation, pulse position modulation. So the examples here are pulse amplitude modulation, pulse width modulation and pulse position modulation. Examples of digital pulse modulation are PCM delta modulation and adaptive delta modulation. So they are PCM, DM, ADM. They are the examples of digital pulse modulation. So now we'll see the figure of analog pulse modulation. Message is continuous, carrier is pulse. See, this is PAM, pulse amplitude modulation. See, look here, message signal low frequency is continuous time signal and this is the carrier. You can see this is your message signal MT and this is the carrier signal CT. See, pulse amplitude modulated signal. Amplitude of this carrier signal will vary according to the instantaneous amplitude of message signal. So it is the analog pulse modulation. Now look here, this is PWM, pulse width modulation. This is somewhat similar to frequency. Width means frequency modulation. This is message signal. This is a carrier pulse. Look here, width of the carrier pulse will change according to the instantaneous amplitude of message signal. When the amplitude message signal is very low, width also very low. When amplitude of message signal is high, width of the pulse is also high. This is called a pulse width modulation. Now look, pulse position modulation. Pulse position modulation should corresponding to the phase modulation. Actually, position of the pulse will change according to the instantaneous amplitude of message signal. This is the message signal. This is the message signal. This is a carrier pulse. So according to that position, but see, look here, the width will be same, amplitude of the pulse will be same. Only the position will be different. It is depending on the instantaneous amplitude, it will vary. See, all of these things, various analog pulse modulation, PAM, PPM, PWM, you will study in detail in unit 1 itself. Also, the digital pulse modulation techniques, pulse code modulation, delta modulation, adaptive delta modulation also be studying in unit 1 itself. Thank you.